Alright, hello everyone, we are back. We had some problems with our recording software. So I think I left when I was just about to make an extension array. So we were making objects and we were going to make an array to know what kind of extensions we have for when we create this type of file. So we have two types at least for YAML. We have YAML and we have YML. So that's the one we use for when we want to put the file extension for YAML. For JSON, we have just one, which is going to be JSON. Right. For TOML, we're going to have just TOML. And for XML, XML goes from there's a lot of history because it already existed with extensible HTML. But what we will use just XML, and I'm just gonna put it like that. So we created our Pisoc present object, so we know when is the date, we know the host, we know what are we going to present. This is a proper YAML file that we can use to describe our event. But I want to talk about something, as I mentioned, when we talk about Boolean types, YAML does this in a way that you might think it's good, but it might also ruin your life. So it's really one side of a coin, because you really have to be careful with what you do. So YAML, as you might think, or just in normal languages, right? You use true to make something, well, evaluate to true. You can also use true with just letter case, or you can make true with everything capitalized. But there is other things that you have to consider when you want to make something true. So YAML decides that when you type on and on and on, the three types of permutations that you can do, they will always evaluate to true. So this might become handy, and it might become your worst nightmare. So you want to look out for these. Another one that it also evaluates true is yes, and all the ways you can type yes. So just like that. And the same thing will then apply to false values. And those would be false. That would be false and false. So all of those will also evaluate to false. Then we're gonna have off, then off, and off. And for our final one, we're gonna have no, or we're gonna have another no, and another no. Okay, so you might think, oh well, I'm never gonna run into a problem like that. Well, I do want to show something. Just want to make sure I can get this right. Alright, there we go. So there was this company that had a website, and they had to internalize it. And we had the UK, Ireland, France, and Germany at first. And they had, well, they had their initials to symbolize what country was it. And as you can see, it's stored in a country array. And those hyphens symbolize each index. But then they decided to add Norway. But what's the initials for Norway? Well, that would be NO. And when you do that, and here they use Python to do it, when you read that, it will give you a dictionary, but with the word false instead of NO, which is what you want. So again, this does give some problems. Do try to look out for these things. So yeah, quick fix would be just putting it in quotes, so you know you're working with characters. But it can also give some other problems. So here again, they wanted the versions they were using, but when they tried to get it, they would get the first one as string and the other one as a float. So it did not work right for what they wanted. Again, they asked to put double quotes in it. And then there's another name, which is Christopher Null, which is normally used to break things. And when you type null, YAML will decide, well, that's not null, that's none. So again, you need double quotes. This does give some problems when you're trying to type something, so you should look out for what you're trying to do. Yeah, so we're gonna move now to to JSON. So JSON is a subset of JavaScript, and you normally use JavaScript to make a website dynamic and do a lot of things over the internet. And what you have to think of JSON is when you make an object using a language, right? You make it, but you don't know the raw form of that file. So when you use JSON, you're basically creating that raw format that the JavaScript uses to make a JavaScript object, and that's very useful for when you want to make an object that's easily usable in JavaScript. JSON is very good because it's very easy to parse. The syntax that it has is very clear and very objective. We'll see that when we jump into that, and it's overall a very good format that we can use. Alright, so it's used basically for any kind of data interchange. Again, its simplicity, I think it's what people really enjoy about it. So when you want to send some data over, you're going to use JSON to do it. Again, it's very easy to make into an object. The data structure that it uses, it's again going to be key value, so the same one as YAML. It's just that YAML again does try to have that object-oriented one, and JSON does it a little bit differently. We'll see when we jump into it. It's also good for web APIs and databases, because again, to send data across a web app or something, you can always use just a JSON file with all the data that you need. You can have like some contact members, right? You can have that in a JSON file, send it over with a JavaScript command, and then everything will work fine. Right, so we will jump into syntax then. So how do we start a JSON file? Well, we'll start with curly brackets. That's how we know we're gonna write some JSON. We're gonna do the same thing we did with YAML. So we're gonna write that. Okay. Again, as you can see, I'm starting to get an error. That's because we cannot have our keys. Normally, when we type our keys, we're gonna have something associated with it. But here, we're gonna have to make it within double quotes. So like that, it would be acceptable. So to make an object in JSON, or how they know that you're gonna enter a new scope, we use the curly brackets, and we're gonna do the same thing that we're gonna do with YAML. So as you can see, it's already very simple because you only use curly brackets. You don't have to worry about this white space that it's gonna could ruin your program. So because if you do something like that, it will break. You're in a different thing right now. Okay, so we're gonna create the same thing. We're gonna have a host, which is gonna be Lucas. Another thing that we have to take care of is we have a comma, which is this. And every time we want to insert a new value into, it can be an object or just variables, we always have to add a comma to separate those kind of values. So we have our present number, and within double quotes, that will be 2. Then again, we can have, one sec, yeah, we can have boolean types, so true, and outside of checking with YAML, right, you cannot have capitalized T. JSON will always just evaluate the letter case true or false, depends on what you're doing. In terms of date, JSON does not have a specific format, so you can use whatever you want. I'm just gonna type it like that, and yeah, that will work fine. Again, you can add your date, but you just want to aim for your data format that you're using, not specifically the JSON that asks you. It lets you be more free compared to YAML. But yeah, then again, YAML does try to be more complex in certain things. Here I would say that, as we can see here, we have a comment. Well, JSON does not support comments, which is a bad thing. Some people sometimes want to develop something in JSON, describe it, but when you go back and read the JSON file, you might not understand what's written there. It does try again to be human readable, but comment is always a good thing to have to describe your data. So we're going to make a nested object now. So yep, we're getting the comma here. We're going to have a description as we did before. We're going to make that an object. So we open again curly brackets. So we know we're inside the description scope. Yeah, so we have a title, and our title will be Lucas. Oh, not Lucas, cool files. I'm not the title. Yeah, so we're gonna then have topics, and topics is well, we could make it an object or we could make it an array, but I think best way to do it is gonna make an array of objects. So we're gonna do it like that. Okay. So we're gonna make YAML and JSON and TOML and XML files. And to do this, every time we want to create an object inside an array, normally you could have something like that. They all have to be separated by commas. But if you're gonna make an object, you have to make it within curly brackets too. So we're gonna make a YAML object. YAML, there we go. And we're gonna again have that extension like we did before. So we're gonna have extension. We're gonna make an array. And we can hold strings with it. So we're just doing the same thing we did before. And that's basically our YAML object. If we want to create another one, we will create like that. Yeah, again, open brackets. We're gonna type JSON. So we create JSON object, which will have an extension. Sublime auto-completing here. We love that. Yep, so come again. Open another bracket, TOML. And we're just gonna do this to every file, so we know we can just do that with everything. Doesn't really matter how much you do. You are free to do what you want, as long as you follow the syntax, of course. Okay, for the last one. And well, as you can start seeing, sometimes it piles up. It does cover a lot of lines if you follow the whole indentation process. As you can see, it's already like 32 lines, at least for it to look pretty. We want it always to look pretty, because programmers, to read something, they always have to make it so that you can actually read it. Okay, so we can see that we made then our JSON file. It's pretty much the same thing we did with YAML. We're not gonna cover this because JSON only has, again, true or false. But yeah, we did the same thing. And you can see that it's kind of close. And a thing I want to mention is that YAML is basically a superset of JSON. So every parser that can parse YAML files can also parse JSON files, not the other way around. Because, well, JSON parsers, again, are not going to be able to read this, because they do not follow this kind of indentation and other things like that. JSON files only try to find the curly brackets, the key values, and only searching for those things, they will not find how YAML works. Yep, we're gonna then jump into TOML. So TOML is interesting. It stands for Tom's Obvious Minimal Language, and it tries to do the same things that YAML tried to do. It does have a different approach, and I actually quite enjoy it. It's very very simple. It's kind of like JSON. It doesn't have a lot of characters, and we'll see what it does. Then again, TOML file, it's very good for configuration files. It is designed to be minimal because its syntax is very simple if you get it. Sometimes it can be complex if you do not get some concepts such as tables. They will use a lot of tables. I will explain that when we go into syntax. And it's open source, so if you want to build your own version of TOML, well, you can just, there's a repo online to just download it. And if you want to support the creator, go and support it. There's always a lot of contributions for this kind of file. Yeah, so I will jump into syntax now, but I will tell then how it works. So the way TOML works, right, if we make something equal to 2, this will mean this variable, it's still key value. It's still like a dictionary, but you have to think that these these definitions, right? So we have a noun in a dictionary, right? And we have some definitions explaining it. But here we are using a hash table. So what that means is that this key gets encrypted first, and then you actually use it. And to do that, normally in a hash table, that means you only have one definition, because that's how hash tables work. So think it again like a dictionary, but only with one definition. So we cannot again do high equals 3 because high already exists and cannot have another definition. But yeah, so hash functions and hash tables, I can explain a little bit of what they are. They're basically, again, the whole thing about dictionary, but when you have a key, they will go through an hash function, and that hash function is something that is used in encryption because it's a surjection function. And what does that mean? That means that basically when you have an X, you can always find the Y, right? So when we have there we have the key high, we can always find the 2. But if I would give you the number 2 or the Y, I could never go back and find the X. And that's basically a surjection function. It lets you find the Y and never lets you find the variable. So that's what's used in encryption normally. And we're going to use tables. And when you create a table in TOML, which I can say already that you do this to create a table, that means we're creating an hash table, and every kind of variable that we're going to create is going to belong to that table. So if we do something like, well then again, host. So this is not like JSON where we have to put double quotas in everything. So host equals Lucas. So we're going to have to use double quotas at least for my name because it's a string. That will belong to the Pisoc present table. If we do create another table, that means that we will forget everything that's before it, and everything that's going to appear after it, it's going to belong to the A table, not to the Pisoc present table. It will forget it. Another thing I can mention is that when you want to create tables, you don't have to go like this. So this is completely fine. You can create a table A and a table B and start writing on the table B and then go back to write on the table A. That's completely fine. What that would mean in data, that would mean basically if you add a description, right, it's just the way you organize data. You would go it like this. So first the description would appear, and then you would have the actual data about our Pisoc present object. So just keep that in mind. It's not wrong to go all the way and do something about it. You can do it how you want it. Okay, it just means that other tables are going to be empty. So present number, we can create all kind of variables here. Again, it will follow the key values, just mapped into an hash table. We're gonna have we live. Again, we do not have tree, just letter case. The date, it does follow a format, so we have to follow it, because that's how programming works. So like that, it would be fine. If you wanna add a time, we'll have to type t. So it like that. And if we want to add an offset, we can use plus or minus. It depends on what you want to do. I'm going to use minus just because, and you can do it like that. So that's how you write a TOML date. Alright, but now we want to make, like we did in the other ones, a description object, right? A nested object. And to do that, we have to, make a table inside a table. To do that, following programming languages, that this would make sense where you just use the previous table and use a dot, so we know that it's going to be part of the previous table. So this way it will not forget that that these variables or the values that are coming now, such as title equal cool files, this title will still be part of the Pisoc present, but it's also part of the description. All right. TOML does get comments, so you can use comments. That's very good. It's just like YAML. And we're now gonna make an array of tables, and this is where it's gonna get confusing, so I hope you're all gonna be listening to me well. because we're gonna think, right? So we want to make a new topics array, but this is not really an array. It's an array of tables. So the topic itself, it's a table, not an array. And to do that, we're gonna make a Pisoc present.description. So we're gonna follow the same tables we already have, and we're gonna make another one. But right, we're gonna make a table of a YAML object, because when we talk about objects in other language, like in YAML, right? When we create it, here we have a topic, right? Creating an object, and a YAML object in our array. We're gonna create tables. That's basically it. It's just every object in the other one is tables in this language. So we're gonna, I'm just gonna copy it, and we're gonna create YAML. But the thing that it will not make sense, right? Because you're probably thinking now, well, I'm gonna create it like that, and that should be fine. Finishing it. Okay, but I want to tell you that this is completely wrong, because this would just mean that these are part of this table, right? But it does not work like that. What we actually have to do is that we have to create a table inside a table. And so basically this is the way you do nested tables, and trying to make nested arrays of tables being the father table, if that makes sense. Another way to look at it is that when you have double square brackets, you have to think of it as you're going to have many instances of it. So the correct way to do it would be to have it like this. So we're gonna have many types, right? So we should have a lot of types, or as we can see, for example, for YAML, JSON, TOML, and XML, right? They're all different types, so they should belong to a different type of table. So that's the correct way to do it. Hope you all get it. Sometimes this is the art concept I was talking about, understanding this table way that TOML tries to do it. Again, you should think it as an object, and it should be easy to understand. Alright, so right now we're just going to do extension and find all of those. You can see, by the way, that they use the equal sign. We're not using this anymore, so that's what to do. So yeah, extension YAML YML with double quotes. Yep, so we're going to do that for JSON, which is going to be JSON, simple enough. Extension equal to TOML. XML, we're going to have the same thing we did before, which is XML, just etc. Okay, as you can see, we did this in a few lines, and the indentation, or the way the scopes work, again, it will be everything inside the table belongs to a different kind of data structure. And we did this in 19 lines, and well, here we did with 31 and YAML, well, 18. But you can see that TOML tries to be very simple, as it does not have those tabs. So when you try to do something like that, that's how other languages try to keep it. TOML does follow a straight line, which sometimes it's very good for your eyes. You don't want to be you know, always seeing indentation. You just have to read straight file, which I think is very cool for a file to adopt that strategy. Yeah, so that's TOML. I do recommend it. Again, as you can see, it's very easy to read when you look at it. I feel like it's a very good, especially for database configurations and things like that. It's very good for configuration files. For storing data too, as it has a way to support comments. And again, it's very easy to parse, because as it is designed to be minimal, it has a very few keywords and characters to look at to actually parse the whole file. Right, going back to our point, I just want to show this this slide where we have how the TOML file normally is parsed, and as we can see, it's looking for keys. If it finds a key, it looks for a value. If we find the key for a table, so we have to find the square brackets, it will just find that and enter a new scope. Comments, of course, are going to be ignored, so we can just, well, ignore them. So it just skips it, just like a new line. Here we have just an example, and as you can see, it's very simple to write it. We just have tables, we have data associated with it, and here we can see they use indentation, but it's not really necessary. It's just the way they do it. We don't really have to worry about it. Alright, so jumping to our last language. Alright, it's XML, or Extensible Markup Language. Now, I hope you at least know some basics of HTML. If you don't, I'll try to cover a little bit of it. It will make some sense when we get into it. XML, as you can see in the bottom, it says my favorite, because I feel like it's a very good way to store some data. What the name means, right? So when you have extensible markup language, right? So markup language is some text, right, that you have. So what HTML normally does, which is also a markup language, is format the text that you have and print out something. It can be text, it can be images. You just you're gonna format that language that you have and make it have a different thing. But HTML, right, it has reserved keywords and attributes such as width, height, pixel. You know, when you're working with making a website, you're gonna work with all those keywords that you have to know. But what extensible markup language is basically an HTML file just without any keywords. So you can make your own keywords, your own attributes, and you don't have to worry about that. And we will look into what I mean when I say keywords or attributes or elements. We'll talk about it. So what is it used for? Well, it's a good way to describe data, and that's because the way it works, right? It lets you, as having attributes, you have to think as XML as a tree. And when you have a tree, right, you have a tag, you have a node that can have a lot of things describing it. You have the value of that node, but then you can have attributes, and those are basically ways to describe that node. And that's why XML is very good for that, because it lets you describe your node, your value, as much as you want, which is very good. It's also good to store data, because again, since you can describe your data very well, it's very good to use this kind of file. And it's generally used across the internet. Again, it is kind of close to HTML, and HTML is the bread and butter of using making a website. And yeah, so XML is very good for whatever you need. And as I say, it's extensible HTML, right? You have to think it that you use it your way. You don't really have to follow any rules, except of course the syntax, but you have to think of it as your own tool to build something with it. Alright, so we'll jump into syntax now. And right, so the way you know you're making an XML file, you have to first write XML, and well, my Sublime Text is going to take care of that for me. And we're going to use tags, and this is kind of like a tag already. So this is basically how you know it's an XML file. We're going to use these Angular brackets a lot, and that's how you define tags. That's where sometimes HTML uses that for keywords. And we're going to have some attributes, and here, for example, we have version and encoding and the Unicode. And yeah, so let me get it like that. So make a tree, right? The root node will be the XML file, the start of an XML file. And if we make a tag now, which is basically the son of that root node, it will be Pisoc present. So right now we created our own tag, and basically what that means again is that we have a son of that root. But we have to remember, and that's how this works. Creating a tag, it means that we're opening a tag, so we have to remember to close it. And to close it, we use it like that. And we have to ident that. So there we go. So that means that everything we type here, it's going to be part of the Pisoc present tag. That's the value of that node. However, we cannot assign things. For example, we can say here, like we did before, oh, I'm just going to put it like that. So that is not going to work, because what we have here, it's just plain text. And we're not formatting this. We can only when we read these files, we're going to check for the value of that node, and we're going to get host equals Lucas, not just Lucas. So you have to think it as plain text, not assigning variable, because again we're using a tree structure, not a data a key name value or key value structure. Right, so to get it we would use Lucas. That would make more sense. That would make more sense if I have a tag called host. There we go. So that would make more sense, because if we search for the node host, which is a son of the Pisoc present object, so we would go root, Pisoc present, and then host. And then if you read the value of that node, we would get Lucas. And that's how also they handle indentation. So nested tags is how they see if something belongs to something or not. Alright, so again, this is just depending on the way you design your XML file, because you could try to read whatever is inside that node and then just try and search for a comma and then read the next line. But this really depends on how you want to build your XML file. We have now the present number, and we could do it like that, right? So we're gonna have present number and then just type 2. But I don't quite like that. So there's another ways to do it, and what I'm gonna talk about now is the attributes. So I'm not gonna make it like that. I'm gonna put it here. So to make an attribute, you have to do it like this. You type the key. It is kind of like key value. It's just the value. It's always with double quotes. And you have to think as attributes normally as metadata. So this is basically data that describes data, and that's the purpose of attributes, and that's why XML is a good way to describe your own data, a very good way to well, add some data. Alright, so we're gonna make another variable, quote unquote variable, because these are not really variables, and it's gonna be real life. So I'm also gonna put that as an attribute, because I feel like it's better to have it here. And then again, when you read this is not technically a 2, and this is not a true. This is just text. So when you read this, you have to be sure that you're casting it into the right type that you're using. So again, plain text. We're not using actual variables here. Alright, so the next thing we have is date. And what I'm going to talk about here is self-enclosing tags. So normally when you open a tag, right, you're going to search for that / to know that your tag has ended. But to do that, we're going to use, you're going to open a tag and we're going to close it immediately. But before we actually go to the end of the tag, we can create attributes. Alright, so we're going to create date. Right, and again, XML does not follow any standard, so we can type whatever we want. So I'm just going to leave it like this. So yeah, self-enclosing tags are just tags that close when they are created. They cannot have a value itself, they can only have attributes. So a node does not have a value, it only has attributes describing it. Right, so what you have left. So we're going to make nested tags now, which is basically what we just did with host and date. We're just going to go basically down the tree. That's basically what we are doing. So we're going to make a description, and again this is going to come back to how you want to design your own XML file. So when you create description, we could go and make this everything could be attributes, but I think in my opinion that would look bad. So the way I'm going to do it is just have a title, and we're going to make a title just a self-enclosing tag because I feel like it will look better, and I'll make value equals to fill files. Okay, then we're going to make an array. Of course, here in XML we don't have an arrays because we're working with nodes and not actual variables. So what we're going to do is just make a lot of nested tags so we know that we have what we want. So we're going to use topics, we're going to close that, and we're going to make 4 objects, right? So we're going to make that YAML, and we're going to close the tag, I'm gonna create it for everything. So JSON. Okay, here we go. And just in case you're wondering, as you can see, trees sometimes get complicated, so it is harder to parse an XML file, because looking for all these values and attributes, going down a tree, it sometimes can cost a lot of power. So to do it, I would say that if you want something fast, I would go for something like JSON or TOML. Yeah. Also, XML does not support comments, but it does support attributes, which is very good. Okay. YAML. So we're gonna make again just another extension tag, because that's again the way I'm trying to think of how to make an array. You can make it in a different way, of course. So we're gonna make it like that. Just first equals YAML. Again, there's another ways to do this. It's just one way, and you cannot type starting an attribute with 1. That would give an error, so that's why I'm not typing actually the number 1. Okay, we're gonna make the same things for the other ones. So extension first equal to JSON. We're gonna close that tag. We're gonna open the tag here. We're gonna do the same thing for everything. Alright, not that one. Close it. Open it. Alright, XML second equal etc. Alright, close it. And that's basically it. Again, what we did with every file, but with XML. So as you can see, they always try to approach things in different way. Again, XML is kind of different because we're not using the key value structure. All of these try to do that. TOML just tries to do it in a hash table. But XML is a tree, so again, be careful using it. Yeah, another thing I want to say is just to finish my talk, is that, let me get this here. One of my favorite games, it's Celeste, they did their game in a lot of XML. If you go into their contents folder, I found that they have a lot of things just described in XML. So for example, I have here some examples. The first one, we have a camera angle. So they have this 3-world map with the camera looking at the level, right? And they can store that in a different attributes. So here we can see that it's area ID 0, right here, and here we go to 9. So again, different levels, and they have a way to describe that. And again, as you can see, the way they do scopes, they have different ways to design this file. Here it's just a way to control how your sprites are working. So if you have a character moving, right, when you want it to make a transition to another kind of movement, so if you're climbing and you're falling, you want that to be smooth, so here just changing those values to suit the character and make it more smooth. And here we just have some character, which is basically just well, it has many expressions, so they just type that here and they record that. So their file probably, or the way they did it, was just reading an XML file, and they would go through that tree and just read the attributes associated with it. And that's basically how they did almost the whole game, which I think is pretty impressive. And this just means that all of these files really have to be used in your own way. You don't really have to think about it, just, oh, I'm gonna use this because, well, it looks good or something. You actually have to think that it's your own way to do it. Another thing I want to touch upon is, again, these files are used broadly. If you go into a company, you're probably gonna find one of these for sure. So do think about learning these kind of files. It's always good to put on your CV, something like that. Some applications that you might need for your software. For example, last week we had Pisoc presents for Docker, and it uses YAML, so it will be a given to know YAML. It will be pretty good. just so you can start using the app. Um, yeah, I think that's everything covering in this present. If you have any questions, I'm here to answer. And yeah, that's everything. We are planning on having different Pisoc presents next week. We're gonna have Git and GitHub with an external speaker, so he's in the industry. He knows how to use it. He knows how useful it can be. We are planning on having way more things. Hopefully, you'll be here to watch us. And yeah, I'm looking at the chat here. It does not seem to be a lot of questions right now. But yeah, thank you everyone for joining us. Hopefully you enjoy this. We plan again to make more of this. And well, I hope you to see you next week then. Thank you again for joining us.